Good evening, ladies and gentlemen. Hello. Hello there, my name is Daniel Bartlett, and this evening I'd like to discuss some of the fun that we had with automating hacking. I'm a member of the Freebox security and development team who enjoy relishing various tasks, development, experimentation with security, anything else that we indulge our ideas. The outline of what I'm going to discuss this evening will be Google and other search engines, what you can utilize from them, PHP, the language, what can be done within it and what can be left to be done within it, the issues of bad coding and what it can cause. The major issue with bad coding would be inclusion of remote files. This allows numerous possibilities which I'll expand upon at a later point. The automation of the whole process is the most interesting. You can start very small and develop quite a succinct method of examining sites and examining systems. A PHP worm, which would be a culmination of many of these ideas, a PHP worm, which would propagate by itself, as has recently happened with the Santa virus, can lead to many possibilities. Numerous search engines will provide you with a succinct source of data for sites, vulnerabilities, issues that they may entail, and can provide a quick method of finding other servers, services, data and sources. Sorry, I'm going to start completely from the start there. Good evening again, my name's Daniel Bartlett. I'm here to discuss automated hacking. And the various things that can happen therein. Freebox security and development team. We're a small group of people who are spread over the world who enjoy research, development, and anything which makes our brain think. We relish a discussion, an argument, or anything that can lead us to a new idea or a new solution. We've been involved in a few open source projects. My most favourite was a live CD generation tool for generating bootable live CDs, of Linux variety, of course. Today I'm going to discuss PHP and the automation of exploiting it, starting off with parsing of data from Google or other search engines, PHP, the language, the issues it entails, the flexibility it allows, and the ease of learning. Inclusion of remote files. This can lead to many possibilities of different things, especially the worst of remote foreign code, which can allow anything to happen on that machine. The automation of these processes is the most interesting and can provide an awful lot of speed rather than the manual process of manually walking sites. A culmination of the automation of these processes would be a PHP worm, which could develop and propagate by itself as a worm would. And a brief analysis of the Santa worm. Search engines provide a structured source of information and sites and pages that they provide. They provide a quick method of finding other services, servers, vulnerable sites, vulnerable scripts that might be available. They allow for target data collation without any communication. You can interrogate a remote host by purely querying its Google results. Search for known vulnerabilities, search for errors in pages. There are many methods of finding vulnerable sites. The PHP language is very easy to learn. It allows lots of various functions to be allowed, various modules to be utilized in the aid of development, and lots of resources to learn from. There are many open source classes and functions to utilize. Local file inclusion. If you can locally include a file on a remote host through varying the variable that's being parsed, You can lead to local file disclosure, execution of scripts in the incorrect context, and execution of uploaded scripts. Execution of scripts in the incorrect context could cause lots of information to be displayed. Information pertaining to a different web application, a different system. Remote file inclusion, allowing for execution of foreign scripts, is probably the most dangerous, since it allows you to be very flexible with what you're doing on the remote box. SQL injection allows information disclosure from any data that is in the database available, or in some cases the root databases if they've left that password available to all, and in some cases the inserting and updating of old data. File uploading allows for the overwriting of file content. Can be used in conjunction with the local file inclusion. A very simple method of protection from inclusion or variable issues would be to parse the data as such. If you know all the correct variables that you're going to expect, you would use the whitelist at the top, and it's a very, very simple function for doing it. If the data you're checking for is unknown, you would use something like a blacklist, excluding any variables or strings that could be utilized in an incorrect manner. During the time I was working on this idea, I was working on an includable script which could be used on many systems. To the time of developing this script, it got hit on many, many times on various servers which it failed. This would cause me great annoyance because it should be working. I would spend hours trying to resolve. Various functions that we built into this script, browsing the file system, probably the most useful for finding information on that system or finding writable directories. Viewing, editing, uploading of files, pretty obvious. Sudo command line via the web client, allowing for execution of remote scripts or remote applications on their system. Browsing databases, be they MySQL, ODBC, Postgres. Simple TCP/IP port scanning, utilizing PHP's inbuilt functions. MIMEs. Installation of a C-based connect-back and listening shell. Simply dropping a C script and compiling it through a system function. The automation of exploiting is less rewarding than manual attack, but is the most rapid. If you take, say, a known vulnerability in a version of PHP and Google the version and take the results, you can tack an exploit on the end with a checksum piece of data and verify the site is vulnerable, as has happened quite recently with the Santa Pearlworm. I originally coded a small piece of C to do just that. Google, parse the results, and then test the results. This would run on X number of processes from the results concurrently, so it was high in bandwidth and sort of on CPU time, but quite efficient if no files were downloaded other than the HTML. Modifying the same tool to work with error codes, you can take the error codes from PHP, Perl, various other scripting languages, and search for common errors. Failing to open for inclusion is a common one with PHP, which leads you generally onto an inclusion issue. If the variable is unknown, take a set of fuzz variables, I like to call them, a set of commonly used variables such as site, page, content, include, and just brute force them with loads of spurious data. This would generate quite a few false positives. In order to overcome that, apply the same testing as you would do in the previous sense. Inserting a remote file which you know should appear with certain data. The more laborious of tasks is walking a site page by page, starting off on the index page, taking every link, taking every piece of HTML, grabbing and removing all links you can and try bruting them. This can take quite a long time to cause results, and it's generally not very accurate. The most rewarding method of hacking a site is to manually try each variable, each page, hand by hand. This is not very quick, but it does provide you with the most reward at the end. and satisfaction. The culmination of the automation of these processes would be a PHP worm. I researched the idea on the internet, but I only found example code such as would infect all the local files on the site, wouldn't do any network infection. I wanted to improve upon this and was looking to find a single script to find sites, test their pages and infect. This task is kind of overwhelming, so I started very low level, starting with a function to walk the file tree and collate all the files that are writable, the directories that are writable, and record these statuses in an array for future reference. Once the infection has started to take place, you would infect the system very slowly, trying to not make it obvious that it was infected. Initially running each section of tasks broken down into smaller sets of tasks to allow for very brief execution time. A method of doing this might be to utilize a status system for each, a saved status system for the process. Every step it runs, it records its status and records where it's got to last time and what it's about to do next. This means you can have very small sections running, negligible to the person browsing the website. The initial set of steps, once infected, or to begin infection, would be arraying the file system, analyzing writable directories on the system, locating further sites to attack. This process would take quite a while to effect as you're searching Google or searching another search engine and collating results. Once the infection is started taking place, the best method I'd thought of for ensuring further actions would be to insert a small image tag into every single HTML page. The person browsing the website wouldn't be able to notice this, but it would be causing an execution each time that image was tried to be loaded. Other options could have been a pop-up, but everyone blocks pop-ups. Another option might have been a frame tag inside the page, but I think an image is just as effective. An option to consider once it has started searching for other hosts to infect and infecting them would be the idea of infecting the local client pages such that an exploit for one of the client users or the client workstations would be infected. So instead of just adding the image tag, you also add another image tag to exploit Microsoft Internet Explorer or whichever your favorite browser is. Furthering the idea of it being a web worm, the idea of it having peer-to-peer between the nodes of the worm adds an idea of redundancy. The current issue which happened with Santa was it was relying just upon Google with a certain search string for its propagation. So that's its single point of failure. Most other worms, when they communicate, have a single point of failure being an IRC channel or an FTP site they're uploading data to. If you build a peer-to-peer network within the web nodes themselves, if you call them that, there is no place of central point of failure. You could, if you conceivably considered it, add on a peer-to-peer front end, so you could cause access to the whole network from a web browser anywhere. Such tasks you might do from that would be a simple webget DDoS or spam distribution, which probably wouldn't be blocked due to it not being in the dynamic IP range and also coming from a valid domain. Another probable update for the worm's core, or another update for the worm, would be the ability to update itself, or to be master updated, especially in the case of someone developing a snort filter for the worm. Further ideas that I've considered for a worm might be mutation or obfuscation and variable replacement, such as in the similar style as updating it for the snort filter. It would be possible to update it and conceal it more so. Taking the idea of the worm on a step or two further would be to have a worm which was multi-language. So rather than being just dedicated to PHP, it would handle ASP, Perl, Bash, whichever scripting language you're working with. This would allow a much larger breadth of infection and a larger chance of survival. And, a brief analysis of the Santa worm. It has only one infection vector, being PHPBB, and the static search string it has for Google. It's being coded in Perl, which is limiting its target host. Not every machine has Perl on. It's not very unlikely not to find one. And the code didn't always transfer successfully. It was only transferring 4K at a time or something strange like that. And it defaces its sites rather than building up any further. And I've run through my talk far too quickly. Has anybody got any questions? Yes, I've got a paper here which I've half written, half read even, sorry.
Is your work available to the audience or otherwise?
Yes, but I haven't got a website with it on yet, so I will put one on. No, I'm not going to get a black on that.